right. Your independent variable is theta, and your dependent variable is r. And one of the reasons I was kind of second guessing myself there is because our coordinates are r theta. Now, in rectangular coordinates, our coordinates are x, y, and your x is your independent, and your y is your dependent. Right? Mm-hmm. That's a good question. I ask myself that all the time. Because when I graph them, I think of the angle first before I think of the radius. It feels like it should be angle comma radians, or radius, but it's not. So I'm sure there's a reason. I'm not aware of what it is, that they decided that this was going to be your independent, or dependent. And this is going to be your independent variable right there. So, most of these equations are either going to be r equals, or you might see it like f of theta equals. But f of theta is like your r here. So, let's look at graphing one of these, okay? We are supposed to sketch a graph, and I went ahead and filled in most of this for you because it could take forever if I made you guys figure out every single one of these, and I knew we would be rushing through it a little bit anyway. So what we're doing here is we're plugging in 0 for the angle. So we would be doing like f of 0 would be 3 minus 3 sine of 0. And on our unit circle, what is our sine of 0? It is 0. So this would be 3 minus 3 times 0, and that is just going to give us 3. So if we graph that point, we would have 0 is our angle, and then 3 right here. And so then we go plug in our next one. So if I'm doing like f of pi over 3, 6 right there. We'll get 3 minus 3 sine of pi over 6. And so we'll get 3 minus 3 times, at pi over 6, these coordinates are square root of 3 over 2, 1/2. What's our sine at that point? 1/2. So we're going to have 3 minus 1.5, which is just going to give us 1.5 right here. So pi over 6 is that second line, and we want 1.5. Oh gosh, they didn't really put the... Alright, so 1 would be like right here. 1 is not shown. Right, it'd be halfway between 0 and 2. So 1 is here. 1.5 is going to be maybe about right here. We're having to estimate a little bit. I wish they had done a circle at 1 and 2. It doesn't matter for these because we're having to graph them. I think decimals are a little bit easier because, like, if you had 3/2 right there, you kind of have to convert it to a decimal to think about where it needs to be for graphing it. So I've done the rest of these for you. I'm just doing the same thing. I'm plugging in pi over 4. And I think I forgot my 3 right here. But I would have 3 minus 3 times pi over 4. Pi times sine of pi over 4, which is square root of 2 over 2. And so I get 2.292 for that. So at pi over 4, I'm at 2.292, so maybe about right here. And then at pi over 3, I would be at 2.134. So pi over 3 is right here. It's going to be a little bit closer. pi over 2 is exactly at 2. Then 2.2, 2 pi over 3 is at 2.134, 2.292 for this one. Then I've got 2.25. I think something's wrong. Something's wrong about this. Maybe not. Okay, let's just keep going. See what we end up. 2.5. Maybe more about here. And then 3 at pi. It's going to be about right here. And then 7 pi over 6, we're at 3.5. So that's getting out here kind of close to my 4 line. 3.7 something. A little closer. 3.8 something. Really close. And at 3 pi over 2, we're exactly at 4. And then kind of go back in, same sort of fashion. Right here, we're right there at. Oh, I skipped. Yep, I skipped. Didn't skip like I should have. And then we got and I am pretty sure this point right here is wrong. What did I do wrong? Or are my points over here wrong? Okay, let's look at Desmos and see what it does whenever I graph. R equals, what do we have? Right here. 3 minus 3 sign. Let's change our background to polar. Print off a blank copy for James. What did I do? All my points are wrong. Did I put a plus? No. I bet I left that off. Here's what I did, I think, is I left. Yeah. Supposed to get 2.5. Yeah, that I left it off. That's what happened. I left that 3 off whenever I was doing this in my table. So we can fix that by let's just take that 3 off of our original right here. So pretend like it's not there. That means I should get a 2.5 right here. So 2.5 be like right here. That's better. And so it's not as pretty of a graph, though. It was a better, even though it's not a very pretty graph, but it's, so it's sort of like this weird, like, circle that's kind of like flatter on top. It's not exactly a circle for that. So that was my fault on the 3. It's a better graph a more interesting graph if I had not left that off. So that gives you an idea, though, of the process of sketching a graph for these. You will not be asked to sketch a graph of a polar coordinate. That's not part of what they ask on the free response question. So you are going to see these in multiple choice form whenever you see them. In fact, I need to look back through the free responses. I don't think there's really polar stuff on the free response questions. So these are going to show up in the multiple choice section. So what you're more likely to see is something like example 2. The figure to the right shows the graph of polar function r equals f of theta from 0 to 2 pi. Which of the following could be an expression for f of theta? So whenever you have this here, you can basically just test some points. So, for example, if I plug in 0, 3 sine of 3 times 0 is going to be 3 sine of 0, which sine of 0 is 0. So I would just get 0 for that. So, like, I'm going to have the point 0, 0 for that graph. Will I get 0, 0 if it's a cosine? I will not, right? Because at cosine of 0, if I do 3 cosine of 0, well, it's 3 times 0, but that's still 0. Then cosine of 0 is 1, so I would get 3. So the cosine graphs should have a point at 0 degrees 3. It should be out here. That is not on my graph. So the cosines are not going to be part of this graph. But answer choice B is still an option because I've got that negative 3. I'm still going to be multiplying it by 0. It's going to still give me 0, right? So try another point. So I would go with probably this like pi over 6 right here for this. So if I do 3 sine of 3 times pi over 6, then that 3, I can put it over 1. That is going to be 3 sine of pi over 2. And I got to think about my unit circle. Sine of pi over 2 is right here. It's your y coordinate. What is sine of pi over 2? 1. So I got 3 times 1, which gives me 3. So at pi over 6, which is right here, it should be out here at 3. That's on this graph, so that looks good. So if I plug in, if I had a negative 3 right there, right? If this was negative instead, that'd basically make everything negative. So at pi over 6, negative 3, now be careful with this because sometimes it is still on the graph. You want to think of this point, pi over 6. I'm sorry, I should just make the angle first. That's what I think of. Anyway, negative 3 pi over 6, then, pi over 6 is right here. But if you have a negative radius, you go away from it. So you go out 1, 2, 3, and you should have a point that hits your graph right here. It does not, so A has to be your answer for that. So that is essentially what you want to do for these questions, is you want to test points to see if they're on the graph or not. So like if we go down to example 3, we are supposed to say which one of these could be that expression. So if I just plug in 0 into the first one, I'd have 2 plus 4 sine of 0. Sine of 0 is 0, so that is just going to give you 2. So I should have 0, 2. That's on the graph, so it's a possibility. If I plug in here, sine of 0 is 0, I'll get the point 0, 2 for B as well, so that's a possibility. Now here for cosine, if I do 2 plus 4 cosine of 0, cosine of 0, right here, is 1. So it's 2 plus 4 times 1, which will give me 6. So I've got the point 0, 6. Is that on my graph? There. 0, 6, not on your graph, so it's not that. This one, I'm going to have 2 minus 4 cosine of 0, which is going to be 2 minus 4, which gives me negative 2. So I would have 0, like 0 radians is right here, but I'd be going away from it to, which is right here. Is that on your graph? Yes, it is, right? So we've only eliminated answer choice C for this one. So next you would want to try something else. I mean, 3 pi over 2 sort of seems like the next thing to check. The reason I'm hesitant on that is because 3 pi over 2, you've got like 3 different points that you hit at 3 pi over 2. So that makes me kind of not want to do that. The problem with the other points is that they're not at grid lines. So I bet we can guess though. Let's try like 5 pi over 4. Right, that's right here. So if I do, for A, if I do 2 plus 4 sine of 5 pi over 4, then that is going to be 2 plus 4 times negative square root of 2 over 2, which is going to be 2 minus 2 square root of 2, because this 2 and this 4 right here can reduce. So well, let's think about it. 2 minus 2 square root of 2, is it going to be positive or negative? No. If it was 2 minus square root of 2, it would be positive. But it's 2 times square root of 2. Square root of 2 is bigger than 1, right? Because square root of 1 is 1. So this is bigger than 1. So this is 2 minus 2 times something bigger than 1, right? So this part right here is bigger than your 2. So that means you're going to get a negative value here. So at 5 pi over 4, right here, if I've got a negative value, that means I should go away from and be somewhere over here, right? So it's not going to be A. So I'm going to try 4 sine theta. So 2 minus 4 sine of 5 pi over 4 is going to be 2 minus 4 times negative square root of 2 over 2, which this time is going to give me 2 plus 2 square root of 2. Okay, I don't know exactly what that's going to be, but is it going to be positive or negative? Positive. Can you give me a whole number that you know it's going to be like bigger than or smaller than or close to? Okay, it's going to be bigger than 4, right? Because 2 plus 2 would give us 4. And square root of 2 is bigger than 1. So this is a little more than 2 right here. So does it seem reasonable that it could be this point right here? Right, 4 would be right here, so it'd be a little past that. That seems reasonable. I'm going to keep that in the running. I probably better check D right here to make sure that it's not also reasonable for that. So if I do 2 minus 4 cosine of 5 pi over 4, I've got, well, do I really need to check this? Because this is going to be negative root 2 over 2. And you're going to get the same thing, 2 plus 2 root 2. So I feel confident that's the right point right there, but B and D still both work for that. So you can pick another one. Yeah. 7 pi over 6 is probably a pretty good one too, because it hits at a grid line right there, right? So let's try 7 pi over 6. So if I do 2 minus 4 sine of 7 pi over 6. So on that unit circle over here at 7 pi over 6, coordinates of that point are negative root 3 over 2, 1/2. So I'm thinking right here, 7 pi over 6. So we're going to have 2 minus 4 times sine is y coordinate, negative 1/2, which is going to be 2 plus 2, which is 4. That's looking good right there, because that hits perfectly at 4. So that, I probably should have checked that one before 5 pi over 4. I was not, I should have seen that that one had grid lines there. If I try cosine, though, I got 2 minus 4 cosine of 7 pi over 4, 7 pi over 6, and that's going to be 2 minus 4 times negative root 3 over 2, which is going to be 2 plus 2 root 3. And that's going to be bigger than 4, which is not the right value right there. So finally, we have found B as the correct answer. So these can be exhausting sometimes. They take a little while to do. Okay. All right, let's do one of these. A portion of the graph of the polar function r equals f of theta, where f of theta equals negative 3 sine theta, is shown to the right in the polar coordinate system. For this, which of the following could be the values for A and B? So this graph has been restricted just to certain pieces of the graph. So we need to decide what is our restriction here. So I'm going to use my answer choices on this to help me narrow this down. So if I use 0, negative 3 sine of 0 is 0. So I got the point 0, 0, which is right here. Seems reasonable, right? If I do negative 3 sine of pi over 2, sine of pi over 2 is 1. So that's going to be negative 3. So I got the point pi over 2, negative 3. So pi over 2 is right here. But we got a negative radius, so that would be right here. Okay, so that's a possibility right there. It could be it. For B, I got pi over, I already just did that one, right? I did pi over 2. Like here, for that pi over 2, negative 3? Oh, yeah, I've written it backwards. Yes. Sorry.
So the B value is the one that's playing in, or is it the A value?
Well, the A and the B are like the endpoints of the increment right here. So they're saying, like, I'm plugging in both of them to see if they are on my graph. Because if they're not on your graph, then it's definitely wrong. And if they're not like the endpoints of the graph, then it's probably wrong. So here, if I plug in pi over 2, I've already done that. That was negative 3 pi over 2. That worked. If I plug in pi, I've got negative 3 sine of pi. Sine of pi is 0. So I get 0, so I got pi 0. Pi 0. I'm sorry. I keep writing them backwards. 0 pi. If your radius is 0, it does not matter what your angle is, right? So that's going to be 0 right there. I've got, now this is, C is unlikely because this is from 0, 0 to 0 pi. So while both of those points are on the graph, is it both endpoints of the graph? So I feel like C is probably out. Pi, I've already done. That was 0 pi. That one is a possibility. 2 pi, if I do negative 3 sine of 2 pi, then that is going to be 0. right there as well, so I would have 0, 2 pi. Again, both of those points are on my graph, but they're just one single endpoint. They're like the same point, so D's not looking good there. Now, any ideas how we are going to decide whether it's A or B, because those are both the endpoints that we have. It is. It has to do with the way the graph is curved. So what we need to do is we need to pick a number between 0 and pi over 2 and see if it's on the graph, right? Because if we're going from 0 to pi over 2, then like say pi over 6, pi over 4, pi over 3, one of those should be on the graph, right? So I'm going to pick pi over 4 because I think it's an easier point. So if I do negative 3 sine of pi over 4, that is going to be negative 3 times the square root of 2 over 2, which is going to be, it's negative 3 square root of 2 over 2. So I'm plugging in pi over 4. Now, I don't know what value that is, but I do know that it's negative, right? So it's probably somewhere pretty close to negative 2 right there. So if I have a negative radius with pi over 4, then that means my point should be somewhere over here. Is it? It is not. So it can't be A. And now to double check that this is going to work, let's try something between pi over 2 and pi. So maybe like 3 pi over 4. If I do negative 3 sine of 3 pi over 4, sine's your y coordinate. You are still going to get square root of 2 over 2. You still get negative 3 root 2 over 2, but we plugged in 3 pi over 4, right? So we would be looking at this angle right here. And again, don't know exact numbers for that, but I do know that I would get a negative number. So I would go away from 3 pi over 4, which seems reasonable to end up about right here. I said I thought it'd be a little bit bigger than 2, right? And that is on the graph. So finally, B is our answer. We are just going to finish this up at the beginning of class tomorrow because we didn't get through it quickly. Like, I probably won't do all of them there. So what I want you, there's no homework tonight. It would be a lovely night to maybe do one of those review things. And they can be done individually. They do not have to be done